Alright, so our next lesson, 3.7, is on arc length and quadrant constraints. So we're going to start with arc length. So arc length goes back to our circles. So if we have a circle and we want to know what is the length of the arc between any two given endpoints. So if we want to know how long is this portion, we have a trig formula that helps us with that. We call this the arc length, we call S. Some other things that we do need to know for our arc length is our radius of the circle, as well as the angle measurement here. Now in geometry, when we had that longer formula, we were always talking about our angle in degrees. This formula only works when that is in radians. So our angle has to be in radians. So if you're given an angle measurement in degrees, you want to convert it first and then use this formula. So our arc length formula is S, the arc length, equals theta, the measure of the angle in radians, times our radius. So we like to remember it as SOR, S, something that looks like an O, R. So S equals theta times R. This is a formula you have to have memorized. So however you like to memorize it, we always say SOR, use the SOR formula. S equals theta times R. So how we actually use this is you're going to be asked to find the angle in radians, or you're going to be asked to find an arc length, or you're going to be asked to find a radius. So we can use this formula to solve for various things within a circle. So here we're given a circle, our theta. The radius we're told is 3 centimeters and our arc length is 4 centimeters. So if we're going to try to find theta, this is our S, this is our R, so 4 equals theta times 3, so theta would equal 4/3 radians. So this would be an example of a radian measurement that doesn't contain pi. We can think of it as the pi was already multiplied in and we got 4/3 as our number. So remember, not all of your radians have to contain a pi. You can have whole number radians. Okay, another type, we're going to still find the angle measurement. Sorry, my circles aren't that great. We're going to go for this theta. And we're told that the arc there is 24. So again, when we look at this, we're given the 24 is our arc, 6 is our radius, so 24 equals theta times 6. So theta would equal 4 radians. So again, this is a whole number radian that doesn't require us to have a pi in it. Now we do more than just find R or find theta. We will have some where we have to find an angle, but they want it in degrees. And so our, whoops, you didn't even see that one, I'm sorry. So our third one, I'll give you a minute to finish writing that down since I didn't realize you couldn't see it. Our third one is going to be find the angle in degrees in a circle with a 6-inch radius and arc length of 5 pi inches. So this one, it's giving it to us in words where we have to draw our picture and then go from there. So this one, I want you to put a little star next to it, because this is one that's like a test question. So put a little star or mark or highlight, because this one is similar to a test question where it's going to be written in words and you have to be able to draw the picture and then solve for whatever you need to solve for. So first thing I'm going to do is draw my circle. I know I have an arc length of 5 pi, so that's my S. I have a radius of 6 inches, so that's there. And I have my theta. So when I plug in to the SOAR formula, I'll have 5 pi equals theta times 6. So 5 pi over 6 would be my theta. But this specifically said, because this is in radians, that it wants it in degrees. So after we have found our radian measurement, we're going to do our 5 pi over 6 times 180 over pi so that we can convert it to degrees. The pi's will cross cancel. I can also reduce 6 and 180, and that would be a 30. So 5 times 30, this is a 150 degree angle. And the one that's on your test is going to be the same, very similar in the sense where you might need to convert after you find the angle, or you might need to convert before you find the missing piece of information. So just remember that theta has to be in radians in order for this to work. Okay, I have one more example for arc length before we move on to quadrant constraints. So our last example for arc length, we're going to find r. So switch it up from finding theta to finding r. Might help again. Oh, you can see that. Okay. So I'm going to tell you that the arc length is 26 feet. Theta is 90 degrees. So again, when I look at this, are my units what they need to be? And I notice that no, my 90 degrees, I have to think, what is that in radians? Because theta has to be in radians. So that's the same as if I say pi over 2. So when I do my SOAR formula, I'll have 26 equals pi over 2 times r. So then when I multiply, I'll multiply both sides by 2 over pi. So that way I can cancel, 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 cancel. I'm left only with r, and I get 50 over pi. Why did I change it to 25? That should be a 26. Sorry, I don't know why I did that. 26, so 52. So then the only thing we want to look at is this, having pi as part of our radius doesn't really make sense. So we actually are going to multiply, or in this case divide, 52 by pi, and we'll get about 16.6 feet as our radius. So just like in 3, how we had to convert at the end, you might need to convert at the beginning to make sure that you have the ability to use that formula correctly. I think there's only like 2 questions on your test or quiz about arc length, so it's not a huge thing, but it is one of those that will be on there. Okay, the second half of this lesson is on quadrant constraints. So if you have any questions on the SOAR formula, hit pause, write them down so we can go over them in class. Or since I'm actually not going to be here, you can email me your questions. I will be available via email. It just might take me a little bit to get back to, but I will. So when you're done writing out any questions, go ahead and start up again on quadrant constraints. So quadrant constraints are when we look at trying to find an angle, or what quadrant an angle might be in given certain information. So one of the things you're going to be asked to do, or at least use this as part of your process, is state the quadrant theta is in. And when we look at these problems, we need to consider our all students take calculus. So consider where are things positive and negative. Because if we look at number 1, sine of theta has to be smaller than 0, and cosine theta has to be greater than 0. So if we look at the constraints given to us about our angle theta, which we don't know what it is, what quadrant does it have to fall in based on these constraints? So in looking at this, I can say, okay, sine is negative, because that's what less than 0 means. So looking at my all students take calculus, I know if sine is negative, it's not here and it's not here. Okay, so I'm able to eliminate 2 of my quadrants based solely on this first piece. Now the second piece, cosine is positive. So I'm thinking, okay, out of what's left, where is cosine positive? Well, it's not positive here, so this has to be in quadrant 4. And so this will help you kind of narrow down where a theta might have to be when we're doing some problem solving. So we're going to do a couple more where we're just going to practice quadrant constraints so that we get a good idea before we jump into the next type of problem using quadrant constraints. So our next one is cosecant of theta is less than 0, and cotangent of theta is greater than 0. So just like before, I'm going to write out my all students take calculus so that I can eliminate the things I know I can eliminate. This one needs us to remember that cosecant and cotangent, even though they're inverses, they follow the same positive-negative patterns as their inverse. So cosecant, which is the reciprocal of sine, that's going to follow the positive and negatives of sine. Cotangent, which is the inverse of tangent, will follow the same positive negatives as cotangent, or sorry, as tangent. So when we look here, cosecant, so sine, where is sine less than 0, otherwise known as negative? So knowing what we know about sine, it can't be in quadrant 1 and it can't be in quadrant 2. Then we look at tangent, or cotangent has to be positive. So from the 2 that are left, it can't be in that quadrant, in quadrant 4, so it has to be in quadrant 3. So that would mean I know my angle lies in that quadrant. Okay, so what does this actually mean for something we're going to do? We're going to get problems that look like number 3 here, where we'll have to do a quadrant constraint before we can, to help us figure out the quadrant so we know what's positive and what's negative. So if we look at number 3 here, we're going to be asked to find the 6 trig functions of tangent theta equaling negative 12 over 5, given that sine of theta is less than 0. And again, you might want to put a star because you do have these kind of problems on your test. So you want to make sure that if you're confused as to how to do these, that you make sure you ask before we get to a quiz or a test. Okay, so what does this all mean? How can we do these with quadrant constraints? Well, right now, based on what I'm told, I'm going to write my all students take calculus. My tangent is negative. So right away, I know that I can eliminate quadrant 1 and quadrant 3 because that's where tangents are positive. So right now I know my angle is either in quadrant 2 or in quadrant 4. The second part here, sine is less than 0. That means sine is negative. So if my sine is negative, it can't be here. So what that means is I know I have a fourth quadrant angle. So when I go to sketch my triangle, or my right triangle, I know it's going to be down here in quadrant 4. So my theta is going to be this reference angle. And when I think about where to put the 12 and the 5, so tangent is opposite over adjacent. So if I go opposite, I notice that I'm going down into quadrant 4. So I'm going to make sure my negative matches the direction of that side. My 5, x is positive, so my 5 has to be positive. My y has to be negative. So you might even, you will need to even look at where your drawing is and make sure that your negative is on the right number. If we were drawing it somewhere else, we would have maybe put the negative with the 5 if it was over here in quadrant 2. So make sure you're aware of the negative and where that should go, and use your common sense about the coordinate plane and where negative numbers and positive numbers fall. So once we have this, we can find our hypotenuse using the Pythagorean theorem. So 5 squared plus negative 12 squared equals our hypotenuse squared. So 25 plus 144, which is 169. So that would give us 13 as our hypotenuse. And now it's just a matter of writing out our 6 trig functions. So sine of theta would be negative 12 over 13. And I can do my cosecant theta right away as well, because that's just the reciprocal, negative 13 over 12. Cosine of theta, adjacent over hypotenuse. And then our reciprocal, secant, 13 over 5. And then our tangent we were given as negative 12 over 5. So our cotangent of theta would be negative 5 over 12. So this one is an example of how we use quadrant constraints to help us narrow down a quadrant so that we can find more information about it. And so just by using this, our all students take calculus, positive and negative chart, we can eliminate what we know it can't be so that we can figure out what it can be. Okay, so I have 2 more examples I want to go over. And it, again, kind of uses our quadrant constraints still. And these are ones that are similar to test questions. So what we're going to be looking to do on these last 2 is we're going to be finding the missing angle. And so we're going to find 2 solutions. Give in both degrees and radians. And we're only going to stick with 0 to 360 and 0 to 2 pi. Okay, so if our first one here, sine theta equals root 3 over 2. So right away, if I think about my quadrants, all students take calculus, I know it's not in these 2 quadrants because I have a positive value. So that means I have 2 possible angles. I have the angle in this quadrant, 1, and the angle in this quadrant, 2. So what I'm going to be looking for is what angle here will give me a sine value of root 3 over 2. And what angle over here will also give me a sine value of root 3 over 2. So if we think about our unit circle, root 3 over 2, that goes with our 60 degree. So I would say 60 degrees for this one. And then over in this quadrant, that would be the reference angle of 60 degrees, which would be 120. So this is reading our unit circle backwards. So we're going to look at the outside and see which sign value gave me this root 3 over 2, and then go backwards to what angle made that happen, and those would be your two answers. So we're going to do one more. Cosine of theta equals negative root 2 over 2. So again, I'm going to start with figuring out what quadrants I'm going to look at. So if my cosine is negative, that means it's not quadrant 1 and it's not quadrant 4, because cosine's positive in those quadrants. So I know it's going to be in these two. So when I go to think about my angles, I'm looking here and here. Cosine's the x value, so negative root 2 over 2 should be what I'm looking for in my unit circle in the x spot. So which theta and alpha give us those two angles? So if we look back at our unit circle, the reference angle of 45 degrees, so the 45-degree reference angle would give us theta of negative root 2 over 2. So in quadrant 2, that would be a 135-degree angle. And then when we move it into quadrant 4, I can do 180 plus 45 and get 225. Now the only thing I just realized I forgot to do on both of these was their radians. So over here for 60, we'd write pi over 3 and 2 pi over 3 for the radian measurements. And then over here we'd have 3 pi over 4 and 5 pi over 4. So when you guys are doing your assignment out of the book, you're going to be doing a combination of all of these things. So you're going to start with some that are just finding arc length or parts of the arc length formula. Then you're going to have some that are going to ask you just about what quadrant things lie in. Then like number 3 in that section, you're going to need to find actual triangle and angles. And then finally ending with 2 solutions based on your quadrant constraints. So again, if you have any questions, write them out, mark them, email me, save it for Tuesday. It's up to you what you want to do, but just make sure you have it noted so that we can get that clarification.